Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another live stream. Let's go. Okay. So just gotta wait a bit for people to join in while I'm drinking my coffee. And of course, I forgot to even share the live stream. Hold on a second. Okay. Looking all good. Amazing, amazing, amazing. Alright, so I did a lot of coding off camera just so we save time, and also that stuff was a bit complex because it involved you know, it's like non-cross-platform stuff, I guess, but yeah, whatever, and some research. So yeah. But I'm going to show you what have changed and why. First of all, let's start by the source code. So here we have main.cpp. Alright. So, not sure, I would guess I would go in side-by-side viewer. Okay. So I removed SDL platform defines, or actually maybe let's start through the main function first, possibly, I guess. Okay. Not sure. Let's just go from the start, you know. Okay, so first of all we have std expect. I added expected ranges too. I'm not sure if I'm using ranges right now, but I was kind of experimenting. Yeah, I'm using ranges, right? So expected ranges, both of these guys are C++23 stuff. I expected in ranges. Actually, ranges, I believe it's C++20, but there's a lot of new ranges in C++23, which I'm probably using here. But anyway, so instead of using SDL platform defines, I'm using SDL. Actually, I basically removed that, right? And then I have only SDL CSWM. And after that, basically, I had ifdef Windows macro define vk platform win32khr. Now, after some research and reading through the source code of SDL and a lot of crazy research, right? I have this solution right here because basically, in fact, I didn't find any solution out there for the particular problem I want to solve. So I just did it myself, and that's what's nice about knowing low-level APIs like Win32, X11, XCB, etc. Knowing how the underlying systems work, although you're using a cross-platform API. So when something like this happens, you already can deal with this situation. But anyway, here I just said if defined SDL enable CSWM Windows. Then I define vk platform win32khr. I define this, so this guy right here would be defined by this header SDL CSWM if it's using Windows. Same thing with Wayland and X11 basically. And basically, if it's used in Windows, then what I'm going to do, I'm going to define Vika use platform Win32KHR, which would basically allow me to use the Vulkan functions of that particular platform, which is in this case Win32. Same thing with Wayland. So if SDL enable CSWM Wayland, then I'm going to define Vika use platform Wayland KHR. You can notice that these guys are grayed out because this guy is not, they are not defined, because right now I'm on Windows, so this is the only one that it is getting defined right here. And by the way, one disclaimer is that this is not tested on other platforms. I just tried my best to write correct code, but let me know if someone tries this on other platforms and it worked or not. So yeah, so Vika use platform Wayland KHR, Vika use platform xlib KHR, and of course Vulkan HPP enable dynamic loader tool. Alright, and Vulkan raii, amazing. So for SDL exception, I just removed git code for now at least, because I'm not using it currently, although probably I'm going to use it later on. But for now, just so I don't get that warning of in use, I just removed it anyway, since I'm not using it right now. And in the SDL struct or class, I just added a little helper function called getPlatform, which basically returns SDL getPlatform, but it wraps it in a string view. That's as basic as that. Right, the other thing that I've changed, I just removed these pragmas that ignored warnings, like the static warning thing, right? Just because it's kind of ugly, and I'm gonna have a lot of the code like this, and I just don't, like, the code is already a bit ugly with the defines, etc., with macros, so I don't want to make it even much uglier. So I just removed them and just disabled the warning altogether. Other than that, I added a new enum called presentation support query error, which is either gonna be failure, in known, or in implemented. And also I added the function show. This is just a helper function, pretty much. I just wrapped SDL show window in a show function here in the window class, as you can see. Nothing crazy there. The other thing, I changed auto here in this get physical device presentation support function to std expected. This is only available in C++23 and possibly even just in MSVC. I think Clang and GCC, I'm not sure if they support it yet, but Clang probably not. They're still not yet, I guess. But anyway, so std expected, this is like a Rust result if you're coming from Rust or Zig, basically. So this is the success type, and this is the error type. So if it's success, then it's gonna return a boolean, that is that device supports presentation or not. Otherwise, it would give this enum that I've defined earlier, which is presentation supports query error, failure, and known or implemented. And coming to think about it, I'm probably going to put this enum class inside of the class itself, so just to limit the scope. I think that would be nice. Alright, other than that, here comes the real deal. Okay. So I kind of struggled to find information about this, but thanks to a Discord server, hold on, let me see, what's the name again? The graphics programming server. Let me actually put an invite for anyone. Hold on a second. Where is it? Let's go, Vulkan. Invite people, edit invite link, never, no limit, generate new link, copy. Okay, I'm gonna put the link in the chat for anyone who wants to join the server, the graphics programming server. You can have some help there if you need it. So let's go send. Did that work? The message couldn't be sent. What? Why? All right, there you go. There you go. I just posted the link to an invite to the server. Okay. So yeah, let's go back to it. So basically, I got a link to the Vulkan spec about querying for WSI support. Now, I'm going to show you this guy. Hold on a second. So as you know, the Vulkan API spec contains like everything you'd like to know about Vulkan basically. And here in chapter 34.4, there is a chapter for querying for WSI support. Here it basically gives you everything you need to know about each platform to get physical device service support, etc., etc. Now, for example, if you have a surface, now this is the function that most people that use Vulkan use, which I didn't want it to use just so I can keep my abstractions sane. But anyway, basically you need a physical device, a key family index, but you also need the surface, you know. So you need to create the surface first, then you can check if it can support presentation or not. So yeah, that's why I didn't want to use this, because it requires to create a surface first, which is not ideal. Although you could go with that way and it would be simpler, I guess, on code. But anyway, so as you can see, for example, Android platform, on Android, all physical devices and queue families must be capable of presentation with any native window. As a result, there is no Android specific query for these capabilities. Now, I was actually confused when I was trying to implement this function right here, which is that I didn't find a variant of vk-get physical device presentation support KHR for Android and for iOS, for example. But then someone linked to me the API spec page, this guy right here, and there you go. This is my answer. Android doesn't need that variant because all physical devices and all key families supports presentation. That's why, but let's just continue with. So here, Wayland, of course, you have to use this guy. All right, Win32, you have to use this guy. XCB, this guy. Xlib, this guy. DirectFB, this guy. Fuchsia, there you go. Google Games Platform. iOS, same thing as Android. Mac OS, same thing as Android. VI Platform, I'm not... oh yeah, VI Platform. Nintendo... oh yeah, the Switch, I think. Switch, if I remember well. But anyway, QNX Screen Platform. And yeah, stuff like that. So that's basically the part of the spec that is interesting for us here. But anyway, let's go back to the code now. But basically, I'm switching on info.subsystem, which basically SDL tells me which subsystem it's using, you know. So in case of it's using Android, Cocoa and UIK, Cocoa and UIK are basically for Mac and, you know, Apple stuff basically. I'm just returning true for all of these three cases. Otherwise, here I'm checking if vk-use platform Win32 KHR is defined. And that also implies that SDL enabled CSWM Windows is there, you know, it's defined too. So implicitly, of course, implied. So case. Now here I'm checking if it's Windows. If it's Windows, I'm using the vk-get physical device Win32 presentation support KHR, and I'm just passing the raw physical device handle. Notice here that I'm actually dereferencing the raii object, so I can get the underlying Vulkan, the raw Vulkan handle instead of the object, the wrapper. So here, key family index. And I noticed one interesting thing is that Win32 doesn't really require anything interesting. It just requires the physical device and key family index, nothing platform specific really. So I didn't have to use any special thing there. For same thing with Wayland, basically a case syswm type Wayland, returning. I'm basically using vacay get physical device Wayland presentation support. And here's the deal. There's one thing that is added from Win32, which is this guy, info.info.wl.display. Now, basically, as we've seen earlier, is that info is a union, okay? It's a union of things. Now, in Wayland, the union, you're supposed, like, when the info.subsystem is equal to Wayland, then you're supposed to access this field of the enum, WL, to access the stuff of Wayland, right? So in this case, I'm getting the display, the Wayland display handle, and I'm passing it to the Vulkan function. Same thing with xlib, although I have some extra things that I'm about to explain. So of course, the same kind of thing. I'm using a Vulkan specific function here, vacay get physical device xlib presentation support. Same exact thing, but here instead of info.info.wl.display, I'm using x11.display. x11 is just info.info.x11, and then I'm passing in the visual ID. Now to get this visual ID, SDL unfortunately doesn't give us that, so I had to do it myself. And luckily, when you actually include SDL CSWM in your project, if SDL enables CSWM X11, for example, is enabled, then that means it will include X11 header and, you know, like basically the system headers. Same thing with, for example, Windows. For example, it would include windows.h, but you got the point. Which is kind of unfortunate because it would, you know, like pollute your names, like your global namespace. But yeah, whatever. Okay, so let's see what I've done. So first of all, I created, of course, this is the X11 code. So I created the X window attribute. And by the way, this is not tested at all. This is just purely theoretical. So let me know if someone have tested it. So X window attributes attrib. I don't need to actually initialize it because I'm going to initialize it using a function basically. Here I'm just, you know, putting info.info.x11 on a variable called x11. Now if x11 get window attributes x11.display x11.window and address to attribute, this is a out reference or out pointer. So basically if this succeed, then this condition would evaluate to true. So we're gonna do this stuff right here. Otherwise we're gonna return SCD unexpected, presentation support query error failure. Okay, so otherwise if we don't succeed, that means that X window attribute is still initialized, not initialized basically, so we shouldn't use it. You should be careful right there, basically it's unsafe. Const auto visual, so attrib.visual, and then visual ID, I use another function called x11x visual ID from visual, and then I'm passing the visual and it gives me back the visual ID. And then finally I can actually use my beautiful function and passing the visual ID. And for in node, I'm just passing instead SCD unexpected, presentation support query error, and known basically. So yeah, for default I'm passing SCD unexpected and implemented. And let me see what I had here though. SDL log warn. So I removed the warning. I actually right now return an std expected instead of warnings. And I removed this get handle because we don't need it right now or currently. I also removed argc and argv. I just removed the names because we do not really need the names since these variables in use. And whenever some variables are in use, you could just omit the variable basically. But of course you should leave the type. And this is what happened here, as you can see. Auto main, I just left the types. And I just said char const pointer const pointer instead of pointer pointer. That's pretty much it. And we have here a surface, right? This is a non-copyable. It stores a vk raii surface gate char currently. Nothing crazy yet, but yeah, surface. Here you pass in the window to the constructor and you pass in the instance, and then it basically constructs the surface. Window.create surface instance basically. Here I just add the const because I can. And here's the real deal. I added some debugging. Now, as we've seen before, that's for some reason vk-config doesn't work for us, so we cannot really use debug layers for some reason. Not sure why that's the case. I mean, I've been using it on Linux and even on Windows sometimes, and it works just fine, but for now, for some reason it doesn't. But in any way, we do need the extension, because if you're going with the Android, for example, then you cannot rely on vk-config, you know. It's like you need to programmatically add the layer. So that's good anyways. So if not defined in debug, so basically the build system would define in debug if it's not a debug build, basically like release, right? So if that's not debug is not defined, and not debug is basically debug, right? So if debug is defined, then we basically add another extension, which is vkxc debug utils extension name. Here, as I've said before, I basically added a helper function just to make this a little bit more readable, of get platform, which returns a string view. Then basically I could just check if it's equal to macOS. This is the old code that we had before. Where is it? There you go. SDL get platform equal std string view macOS. Pretty much. Extensions in place back. Okay. Other than that, let's see. Here after the instance, I'm adding the debug utils stuff. This was an interesting thing because I never really done it even with raw Vulkan, because I never had to, because I was using vk-config, but right now I was forced to do that. But anyway, it's pretty interesting. So you just create a debug utils messenger create info exe. Here I set the message severity to everything. You can pick and choose whatever severity messages you'd like to get. There's also message type, general, validation, performance, device address binding. I just taken all of them for now. And here the pfn user callback. This is the callback will be called, and basically it passes for you message severity, message type, p callback data, and you should return a vk bool 32. As an application, you have to always return SDL, sorry, not SDL. You have to always return false. Like true is only for layers developers. I'm not sure why that's the case, but yeah. So as you've noticed here, I always return vk false. But anyway, here I have const auto log. So I'm defining a function, and it contains a closure, right? And that closure takes one parameter, which is the message severity, okay? And here I'm basically just calling the closure inside It have a special name when you basically create a closure and call it at the same time. I don't really remember the name exactly, but whatever. And what I've done here, I switched on message severity. And in the case of vacate debug utils message severity flags bits xt, if it's error, then I return SDL log error, the function SDL log error. I return a pointer to that function. If it's verbose, I return SDL log verbose. I felt like a genius when I done this. Info, SDL log info, and warning, SDL log warn. And default SDL trigger breakpoint. So if there's anything other than these enums, which should be the case, if for some whatever reason, for example, Vulkan maybe added another enum kind to this or something, then we would just trigger a breakpoint. This would basically, if you are on debug build, it would break. So you can know that something is wrong with that, and you can investigate it further. And here I'm just saying std unreachable to end it, because the compiler doesn't really know that after trigger breakpoint. Not interested into running more code, so here I'm just saying unreachable. Unreachable isn't defined, by the way, if you reach it in release builds, but yeah. So yeah, whatever. Const auto message type string. Now, by the way, why use the closure? So the nice thing about doing it this way is the fact that you can actually define it as const, which is quite amazing. And also it simplifies the switch. Now you do not have to say every time break, 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 break. You just say return and you return the thing. So that's amazing thing about closures. Now we have the message type string. Now, thanks to the HPP header, the Vulkan HPP header, we have a beautiful function called toString, inside the namespace vk. And you basically have to pass it the message type, and it will give you that message type enum as a string. So I do not have to create a switch myself and try to switch on the enum and give it a string. So it's already done for me in this case. But surely I need to static cast first, as you can see here. Why? Just simply because from the callback, I'm actually getting, where is it? From the callback, I'm getting vacate debug utils message type flags ext. This is the raw enum, okay? But then I'd like to, like, the raw enum is just an int, it's like all raw enums, all raw C enums are just ints. So this guy cannot be overloaded on ints, So first of all, I convert it into the wrapper type kind of thing, into the HPP type. Then I try to go with this because toString is overloaded on this type to do the job basically. And then after doing this beautiful thing, I could call log whatever it is it log error or log verbose or whatever. I just give it log category application, and then here's the format string. I pass in the message name, a message ID name, and then message type string. Now notice here that I use .data because, well, this is the C function. It doesn't want the string, it wants a pointer to the raw string, right? Of course, null terminated string. And of course, make sure to not do vacate toString.data. I'm not sure if it would work here. I mean, if it's a literal, it would work just fine. But don't play it safe and never ever do such a thing, because you risk basically the function getting deallocated, and then you basically have a pointer to destroyed. object or destroyed string, but whatever. Basically a dangling pointer, which is not great. So I just pass in .data here. Here we pass in the message. This is the actual message. And of course for vk false, and yeah, vk raii debug utils messenger. Here we're actually creating the object. So we're passing instance, and the debug utils messenger creates info. As simple as that. Okay. Other than that, I actually delayed the construction of a surface for later, because we don't need it at this point in time. Or in the code, should I say. But anyways, here we have the window, and I just casted this flags to SDL window flags, because apparently when you OR these enums together, you get an int instead of the same flag type for some reason. So yeah, I just casted them back to SDL window flag so it can accept it. And here I just added a SDL window hidden flag. Why? Because the creation of a surface takes some time, and if you don't make the window hidden, like, it will show the window either having trash content, or it would be like black, for example. Then until the surface gets created and you render into it, then the window, you know, the user will show. So I just avoided that by making the window hidden at first, and then I will show it when it's ready for rendering, basically. Here you do not have to do this, but I just used another recent C++23 feature, which is ranges views. So instead of having a row loop, etc., like I've done before, right now I use std views. Although the problem with this is that it have this nasty warning or error. At least it shows me as an error. But in fact, this is just a problem, I think, with my IDE. Like when I tried it in Visual Studio, for example, it didn't really tell me that this is an error. And in fact, the code compiles just fine and runs just fine. So yeah, here const auto key family index, blah blah blah, std views. So basically here what I'm doing, this is equivalent to enumerate in Rust and Python or whatever. And in fact, there is a new function coming into C++23, which is an enumerate view, which does exactly this. You just say std views enumerate, and then you pass in whatever, and it would just do the job. But sadly, it's not implemented yet in MSVC, so I had to use an alternative, which is zip. So I used zip, and then I used iota, and basically zip takes two iterators, you know, or should I say views, and I don't know how to but basically it gives you one value from each iterator, just like in here. So, and iota basically generates increasing values, like, and here you say from which you want to start. In my initial value here is 0. I set it to 0, of course, because we want to start at index 0. Okay, so that's why I have key family index. It's coming from this std views iota. And then I have physical device get queue family properties, which is coming, so queue family properties, right? And as you can see, the code is much cleaner and much safer and much nicer, because we have no row loops there, etc. So yeah, I didn't need this. I don't need this anymore because I'm using that. And yeah, pretty much. And here, one nice thing about std unexpected coming from Rust, so there does support presentation, which of course returns to you std unexpected. Now here what I'm saying, at least for now, if there is an error with the querying physical device presentation support, I just return true. That's why I said, so either give me the value of the success, otherwise just give me true, you know. So basically here I'm enwrapping that expected value, that result. So pretty much it leads to much cleaner code. Here, queue priorities. For now, I just set it to use an equal, because if you don't use equal, if you use the initializer, this would be a float instead of initializer list. Just to avoid confusions for other people, I just decided to use an equal there, so it's always an initializer list instead. So yeah, pretty much here we have an STD optional. So this is some new stuff. Interestingly, now I could have used a surface KHR here, but I decided to wrap the surface KHR in surface because I'm going to add some other stuff later, which I'm gonna show you, but whatever. Here, STD optional surface, and of course, at first there's gonna be no surface, nothing, so null optional. And then, so if not defined Android, so if we're not compiling for Android, then we're basically going to construct the surface directly. So as you can see, surface.inplace window comma instance, and I'm using in place so we can construct the objects in place basically. Yeah, and here after doing that thing, I'm just showing the window because we're ready at this point. So for auto should false, here I just use the for loop instead of a while, just so I can limit the scope of this should close variable into this guy, into the event loop basically. So yeah, and then of course I made sure to I actually forgot to do a break here, which would have been a disaster, but anyway. So here I added the break, and then after that, if defined Android, now notice this is if not defined and this is if defined. So if defined Android, then I'm seeing if the event is an SDL event did enter foreground, then basically we're going to construct the surface at this point. Now if it will enter background, then we're gonna reset the surface, which means we're gonna destroy the current surface, and you know, just wait for another SDL event did enter foreground. Now why this is the case, why we need this kind of two execution path or whatever, because in other platforms it doesn't matter, you can like just create a surface and it will still be valid for the whole lifetime of the application, hopefully, unless if something very unexpectedly wrong happened, which you cannot do anything about. But on Android, you can only create the surface once your application gets this event, did enter foreground, which is the equivalent of on resume on Android. On resume event, and this guy will enter background, which is the equivalent of on, I believe, on pause. I don't really remember exactly, but yeah, something like that. Event on Android. Now Android, as I said, requires you to create the surface once you get an on resume event, and destroy the surface once you get an on pause event. Because at that point, when the application goes into the background, the surface is invalidated. If you use the surface for anything, you risk crashing, you know, it's like it's invalid at that point. So yeah, pretty much that's why we have this kind of and I wrapped the surface in an object, because whatever we want to do with the surface, it's gonna be collected into this guy, so it could be destroyed and recreated collectively, you know. But yeah, so that's pretty much it for the changes I've done off camera. Now there's a lot of things to improve, and also I also added this vis file, which you can actually find in the header, in the GitHub repo of Vulkan HPP. And I found this very interesting. I'm not sure if a lot of people knows about this. Surely if you read the README of the repo, then you would know. But basically, in the repo there is something called There you go, Vulkan hpp.natvis. And if we search for that guy in the README here, there you go. So custom views Vulkan HPP objects in Visual Studio. The file vulkan.hpp.natvis provides a custom view on vk flags for Visual Studio. If you add this file to the user-specific natvis directory for your Visual Studio installation, you get vk flags nicely formatted in your debugger with all your Visual Studio projects. Now the thing is, so basically what I've done here, I just added this file, that's Vulkan HPP natvis file into here. I may use CMake later on to basically fetch the file from the repo freshly directly into my repo, but for now this is fine. I just copied it over from the repo into my root directory. But why I added that, or what this effect? Well, basically, let me show you. For example, let's see. Okay, for example, let's say we are here, okay, whatever. Actually, no, it's not gonna hit that because we're not on macOS. Hold on. Let's say, actually, let's go with something like this, okay. Let's say we are debugging, okay, and I wanted to check, let's say, the create info struct. Now, in the enums like s-type, flags, well, not this one, I want the other one, this one, okay. So s-type, flags, message severity, which is also an enum, etc. It would just show you a number, because in fact in enum, really in the actual generated code, it's just an integer, really. But when you add that natvis file from that repo, you actually get in your debugger what exactly those enums are. So in my case, as you can see, this 4369 is e-verbose or e-info or e-warning or e-error, basically. So that's very, very useful for debugging. So yeah, that was it pretty much. Now, I think I've basically covered everything, hopefully. So now when I run the application, of course it runs. And of course we have finally debug layers. So you get messages about performance, about, you know, verbose stuff, whatever. So for example, here I got a loiter message. It's info, general, that's the message type, inserted device layer, vk layer, OBS hook, and tell me the path, NV Optimus, and here it tells me using NVIDIA GeForce GTX 1650 with driver, and it tells me the driver. This is just messages from the debugging layers. But if I switch on to release mode and I run this guy, it's gonna take some time because it's release mode after all. And there you go. As you can see, I'm getting no debugging stuff, because in fact, if you notice here, it's grayed out. Everything that has to deal with debugging, it's grayed out because I didn't enable it in that guy. Okay, why? Too simply because debugging layers will really hurt performance. It's only meant to be used for debugging and basically debug builds. But for your release builds, you typically want to basically you know, remove it completely using compile stuff, like if not defined in debug, etc., or just use a variable. And but you got the point nonetheless. Depends on if you want to basically switch between enabled and disabled for your debugging layers, or you just want, but whatever, I just prefer this way anyway. I may actually use in the future const expert instead of macros, but yeah, you got a point, hopefully. So that was pretty much it. I think. Now next up, anything that have to deal with the surface, I'm going to hopefully do it here inside of this class. So anything that depends on the surface would be recreated, destroyed, created, etc. with the surface, you know. So I don't have to, every time I have a new object, I have to always go ahead and add it like here. So to make sure that whenever I destroy the surface, I also destroy those objects and etc. etc. So pretty much that's it. For example, the swap chain, I'm probably I'm gonna do it inside of this surface thing, right? Because it needs to be recreated when the surface gets recreated, of course. And in fact, even the swap chain needs to get recreated when some cases happens. But yeah. All right, so it took me around 45 minutes just to explain what I've done here, which is crazy. Now imagine if I have done this on camera. It took me quite some time to figure out myself. But the nice news, though, that you do not have to do this kind of function. You do not have to create it yourself in the future. Why? Because in fact, I opened an issue in SDL GitHub repo. Issues. And there you go. So here you go, I opened this issue, add a Vulkan utility function to query physical device presentation support without the surface. Add a Vulkan utility function to query physical device presentation support without the surface. I found absolutely no resource on how to do this, so this is just my take on it. In my recent C++ project, it's also insisted on platforms other than Win32. So as you can see, I just gave them my code, so if anyone wants to implement it to SDL, they can have a easier time implementing it just by looking into the code and figuring out what I'm doing here. And of course, it seems like they added it to the 3.2.0 milestone, so we can expect that maybe in SDL 3.2.0 we would have such a function. And if they added it, when they add it, I'm just going to change my code. I'm going to remove that function and use their code instead. And yeah, I no longer would have to go through system headers and doing some crazy stuff myself. SDL would take care of it. So that's amazing. Can't wait for that. All right, so that's pretty much it. Now, one little thing about the debugging layers. Where is it, debugging layers? Now, one thing, in fact, there's a lot of things, but you get the point. Anyway, so, where is it? Let me switch back to debug, okay? There you go. Yeah, so in fact there is a lot of crazy stuff inside of p callback data, a lot of data that you could use to log better messages and more, and you could also use this guy right here. So there's another parameter, if you have noticed, it's a void. Now here this is a user data, but since I'm not using it currently, I'm just removing the name. But basically you could pass anything, like whatever you pass as a user data in, where is it? Yeah, in your debug utils messenger creates info, whatever you pass there, for example, a struct or a login function or whatever you pass there, it will be passed by Vulkan every time to your callback right here. To your callback. Through this guy, and then you can basically cast it to whatever type it is, because of course once it goes through the Vulkan stuff, it would not have a defined type, so you have to cast it yourself. And then you could use it however you want. For example, let's say you have some logger, you're not using a global function to log, let's say, for example, or maybe you have some struct that you have stats upon what errors happened, how much errors, whatever, etc., etc. Then you could basically pass it through this guy and you could use it. So that's the first thing. Second thing is that currently we're not getting debugging stuff for creating the instance itself, because the instance gets created before the debug utils messenger gets created. Now, fortunately, there is a way to actually fix this, which is through I don't even remember what it's called, but basically something with chains on it. Call chain, I guess, I'm not sure. Anyway, but basically in your create info, you can find something called a pnext pointer, which usually you just set to null and just forget about it every time. But sometimes when you want to do some extensions, when you want to extend the struct, you use those chains, those pnext stuff. And in fact, by the way, if you don't know, since we're using Vulkan HPP, we don't really have to care about this. But if we're using the raw Vulkan API, then we'd have to set manually S type, and we would have to set it to the structure type as an enum, which this is useful for because of those pnext stuff, because you extend the struct. But whatever. But in my case, the call chain, I don't have to deal with pnext. I have a much better solution, a much better type safe solution to do that. And honestly, I still didn't try it. In fact, I never done it before. I'm gonna done it on camera, hopefully right now. So yeah, let's have a look. So let's look for call chain, I guess, or no, chain. Yeah, structure pointer chains. Let's go. So Vulkan allows chaining of structures through the pnext pointer. Vulkan HPP has a variadic template class which allows constructing of such structured chains with minimal efforts. So I'm just gonna read through this real quick. Now, the amazing thing about Vulkan HPP is that it's type safe. It checks stuff at compile time. Instead, that if you're using just the raw Vulkan stuff, you're not gonna have compile time errors. You're gonna have runtime errors if something goes wrong. So this will compile successfully. This will fail. Why? Hold on. So here we have memory allocate info. Here import memory FD info and memory dedication requirements. Oh, I got you. So of course you cannot extend the struct with anything you'd like. That doesn't make sense. For example, here you can indeed go ahead and extend the memory allocate info with an import memory FD info khr. But you cannot, of course, extend it with memory dedicated requirements khr. So this would fail to compile. But if you're using the raw API, this would not fail to compile, but would fail at runtime in the client's code. So in the client's environment, sorry. So yeah, Vulkan HPP provides a constructor for these chains similar to. There you go, nice. So you basically create a structured chain here in the template. You basically provide the chain, right, in a variadic template basically, and then here you construct each one of them. Interesting. You can even remove them using inlink. Interesting. And you can even relink it. Okay. Pre-allocated structure. I guess this is maybe when you already have a chain that you have made and you want to basically kind of get it. I'm not sure, but anyway, we probably don't need this anyway, so to get just a base structure. All right, amazing. So that was it, right? We could try to figure it out ourselves, but there's no need, because in fact I'll show you a better way, which is to go through the raii samples in the Vulkan HPP repo. Okay, and if you look for debug utils messenger, there you go. So if you look into here, you're gonna find a CPP. And there you go. This is from where I kind of redid the code and tried to simplify it down in my code. But anyway, so for me, I just used the closure to inline that callback function. But they actually used it like they just declared it as a freestanding normal function, regular function. But of course, if you use a freestanding function, you have to use vk API call and vk API attr. This is to define the call convention. But since I'm using a closure, I do not have to do anything like that, because it would as much as what I understood is that it would do that for me automatically when using the closure inline. So that is amazing. Here it looks like it's checking if it's Win32, then it's basically displaying a message box for some reason. Otherwise, it just see out. So you can read through this to get more information about what's possible with the debug callbacks. There's a lot right there. But yeah, for now, it's fine. Okay, find if. Now I'm looking for that guy application. Where is the chain? Doesn't seem like it's here. I guess it's probably in the other guy, so hold on. So we have looked in, I guess, in there. This is the one that we have checked. All right, let's check the other one. There you go. So it's using a VKSU right here, and when I was first reading through these examples, I found it very, very confusing. There's no comment on what is SU, where is it coming from, etc., etc. But luckily I found it out. And by the way, just a little trick, don't tell anyone. If you are on a GitHub repo, you can actually press the point key, the dot key, and you get VS Code online on that repo. Not a lot of people knows about this, by the way, and it's very interesting. And there you go. I have an IDE online on the repo. I didn't have to clone the repo, nothing really, just web. Amazing. So if I click on SU, it would tell me where is it defined, just like in VS Code basically. And there you go. There's a lot. Basically SU, I believe it stands for simple utility. But let's go. Now what we're interested into here right now And in fact, not this guy. Hold on. So it's actually defined in multiple places. I do not remember, but I guess utils possibly. Yeah, probably utils. Okay, so inside of utils, which is inside of raii samples. Okay. So basically these are some utility functions that they're being used by the samples. But here I'm going to check for structure chain. Let's go. And there you go. They're doing it here. So if not debug, so if defined not debug, then we're basically just going to do a structure chain of one element, which is the instance create info. Otherwise, if we are, so basically if release, then we're doing this. Otherwise, if we're not on release, if we are on debug, then we're going to do this guy, the same guy, but we're going to add another structure into the chain, which is debug utils messenger create info. And with that, we also get debugging messages about the instance creation, which would be useful. So yeah. And of course they're calling another function, but right now, first of all, let's do this guy. So yeah, let's see. So here we have vk raii instance. Interesting. So if defined and debug, so basically if release, then what we're gonna do, oh, I see what they're doing here. So the type, okay. Well, I guess maybe I would just use using, maybe to simplify it, using instance structure chain is equal to. Now honestly right now I'm just gonna remove the macro until I finish writing it so I can get IDE assistance. Okay, so using instance structure chain equal to vk structure chain, and here template, and you give it basically vk instance create info, and vk debug utils messenger create info. Now just be careful because there is a lot of stuff like there. Let's go. And yeah, so basically if defined in debug, which means the release mode, we're gonna do something else, and if and basically if it's not debug, if it's release, we're gonna remove this second guy and we're just left with this guy. And basically here, instead of having to do this, I just using an alias, and I define the alias depending on the build mode. So yeah, now I could basically say instance structure chain in both cases. Now let's see how we can actually create. We return vk raii instance. Oh, gotcha. So we still need this guy. So you give it the context, then the instance create info chain. Dog, but anyway, let's see how it creates the info chain. It passes in the application info, enable layers, enabled extensions. Okay, so let's go into that guy. Let's go, and there you go. So if not debug, just like we had before, basically. In debug mode, additionally, use the debug utils messenger callback in instance creation. All right, this is interesting. I'm just gonna cut that guy and go back for a second. What I had before though. Okay, never mind. Let's just get it back. So before creating the instance, we gotta do this. And basically here, in fact, let's go back to the structured chain. What? Let me have a look into this guy. What the, where is it? There you go. So we just say .get vacate instance create info. Okay. So here we have to say it's kind of weird, isn't it? So this gives us the create info chain. So we already have the chain. What? The defines are making the code very unreadable. And the indirection .get. So I need to do this somewhere. You pass it to create instance, but what create instance gives? Create instance. What? Really? You actually have 10 definitions or what? What? So confused at this point. Create instance. It's calling itself or what? I'm so confused. It seems to me like it's calling itself somehow. Weird. Really? This is another level. I guess I'd better just try to do it myself. Okay, try to figure out myself, I guess. So, of course we need to create an instance, but let's see what is possible. Of course, seems like you always get a context. And then you either give it a that or that. Create info. So I would guess if I understood well, then maybe I can basically give it the instance structured chain, but then maybe .get vacate instance create info, I guess. It's very weird, but okay. I think that this is how it's supposed to be like. Right. Right or no? Okay. Now, of course, we have to create this debug messenger stuff before. Okay. All right. Now, I think before the structure change stuff, I could put that guy there. Maybe after, anyway. And now what I'm supposed to do. Okay, so in not debug, basically in release mode, I would just create my instance create info stuff normally. But you pass, I guess, an empty thing there, or what? Yeah, so this is the vk create instance stuff, instance create info, and then this is for debug utils messenger. Gotcha. Makes sense. All right. So how to do this? So I guess I do not need that instance thing, I believe. Severity flags. What? Yeah, this is so annoying. Like, it's using that kind of. Where this guy's defined? What? Okay, so there's S. Come on. Well, I guess I just gotta figure out myself again. Alright, fine. So unreadable. Debug utils messenger. I think maybe do not need this anymore. So here we're creating the debug utils messenger create info, right? Right. And here in fact you already have an ndebug here, so you know what, if not defined though. So I'm gonna put this guy with the other guy. But no, can we really do that? We have to have the instance structure. Oh my. Well, let's just go back for a second there anyway. Weird. Okay. I mean, yeah, I guess it makes sense. Oh my god. I'm so confused. So, in debug, the instance structure chain take two things. yeah, it takes a instance create info, and I guess a debug utils messenger create info. Okay, so do we have an instance create info here? I guess. I mean, we should. Where is it? It's called create info. I should rename that honestly, but anyway. So I guess here you would say create info, and then here you would give it the debug utils messenger create info, I guess. Hopefully that's right. It seems to be fine. Seems to be. Other than that, in that case, you would just say this in release. Okay, in release you do not need this guy, just the create info. Am I doing that right? I think so. I think so. Let's see. And the moment of truth. And let's go. Okay, I think it works right now. As you can see, we're getting much more debugging stuff, debugging messages. So checking for layer manifest files in registry. So I think this is coming from verbose messages. Basically, it's telling me about the loiter, what it's doing. First of all, it checks for layer manifest files in registry, located JSON file. Okay, so as you can see, it gives you a lot of crazy things right there. Amazing. Amazing. So we have done it. Now, let me see if I can simplify this code a bit. I don't need this guy though. So that's interesting. Very interesting. Now, honestly, since I have that code in the same place, it honestly just makes sense to do it inline. I guess no need to do it this way, isn't it? Yeah, I think so. Same thing here. Just do it. Where is it? Here. So yeah, that's pretty much it. Amazing. Amazing. Now let me make sure it's working on debug and release builds. Okay. There you go, debug works. Let's check release. And there you go, working great. Amazing. That's what we need. All right, now the other thing that I'd like to show you is layers. The API dump, to be exact, it's pretty interesting, especially for a beginner. So I'm just gonna show you that it is possible. Where is it? Let me see how I can do it. Yeah, so you could basically have layers like this, and then vacate API dump. Where is it though? Not sure where I'm supposed to find it though. Hold on. Something like that. I would guess it's maybe layer name. Oopsies. Well, maybe there's no constant for it? Possibly. So I guess maybe I just have to tell it that as a string. So well, let's try it out, I guess. And then basically what we can do, you can say create info dot set layers, layer names, okay? And then pass in the layers. Now in my case I could just pass them directly in this case, since I do not have any dynamic stuff, I guess. Let's try it out. It doesn't like it, I guess. Yep, so I guess maybe I cannot. So let's pass in the layers. Seems to be fine. Now let's see if this works. I didn't use layers, like, I think since I started learning Vulkan, maybe. There you go, an exception. What's this exception is all about? Error layer not present. Okay, nice. Nice. So it couldn't find this layer, this particular layer. Well, let's check for Vulkan. I always forget the name. I guess Vulkan caps viewer. Hold on, let me get a terminal here. Vacate. What? Why it's not? Well, let me get a terminal. Vacate. Okay, it doesn't seem like it's accessible from the terminal. So I think I need to go to the SDK actually. Okay, Vulkan SDK. There you go, inside the Vulkan SDK version. And where is it? bin, I believe. And here's the layers. Where's the API dump layer? There you go. But let me just use Vulkan caps view. Let's go. There you go. Now let me check maybe the layers. That's extensions. Is there no layers there or what? There you go, instance layers. There you go. So this is all the layers that are possible for my system at least. So this is the name. Let me see if it's right. Well, yeah, but for some reason it didn't work. Weirdly enough. Huh. Weird. Oh, well, that's extensions actually. Okay, operating system, Windows. So I don't know why it doesn't work. I mean, I could go ahead and basically query for that layer, etc. But for now, I think this is fine. I may experiment with it later on, but yeah, whatever. It would have been nice to show it, but it doesn't seem like it's working now for some reason. So yeah, that's pretty much amazing. Now I'm not sure what to do next. I did have some idea, but I forgot. Okay. I think we're probably ready right now to create, for example, let's say swap chain, I guess, for example. So maybe let's try to do that. Let's see how we're gonna do it. Well, raii surface. So here in the constructor, I'd like to create basically a swap chain. And for the swap chain, I'm also gonna have its own class, since I'm also want to actually recreate this, etc., etc. Non-copyable for now. Okay, now swap chain, I guess. Okay, and yeah, they should be public, of course. Well, whatever. So next up, we would create a swap chain. But of course, this is optional. This should be optional. So SCD optional, because you may not always have a swap chain ready, I guess. Maybe, we'll see. Swap chain. Okay, typo in word, swap chain. Save swap chain to dictionary. So, all right, amazing. So now let's see how we're supposed to actually create it. Well, the swap chain, of course, will contain the vk raii swap chain. I may actually call those guys handles, really. Yeah, let's call it handle, just so we don't confuse ourselves. Okay, cool. And yeah, now we basically need to create a swap chain. How are you gonna do it? Comma swap chain. Okay, for now this is it, I guess. But of course, you're supposed to be able to recreate the swap chain later, etc., etc. But now, this is nice. Okay, so now we can hopefully try to create a swap chain. Delete it here, make structure. What? Default. No. Okay. Handle. So this requires a device. What? Well, anyway. So this requires a device and a vk swap chain. Right. Or a swap chain create info, of course. Okay. Create info and allocation callbacks is optional. So right now we're gonna have create info. And create info. Well, in fact, do we even need that at this point? Yeah, we could just use the default constructor, honestly, I guess. Right, maybe. So whatever. So let's try to create a swap chain create info here. I was kind of confused right there for a second. Okay. So swap chain create info khr, swap chain create info. Okay, let's see what we can set here. Oh well, of course, surface equal to, well, handle, I believe, right? Actually no, I think I need to dereference it possibly. Yeah, to get the underline type. All right, swap chain create info dot flags. I don't think I need any flags. Clipped, and this would be false by default. I do. Actually, let us check the documentation real quick. I don't remember a lot. Hold on. Where is the registry though? Yeah, I gotta add that vacay thing. There you go. Okay, where's clipped? Specifies whether the Vulkan implementation is allowed to discard render operation that affect regions of the surface that are not visible. Yeah, okay. So for now, I'm going to go with the clipped equal to true because, like, I do not really care about clipping right now. Anyway, well, whatever. So basically, if you want to capture, like, well, I gotta try to explain this. So let's say, for example, this window, okay? Now there is another window behind it. Now the stuff that is behind this guy, if you set that to clip to true, then Vulkan is allowed to basically discard the stuff that is not rendered because of the clipping of this window on this on the other window. So basically, if you want to actually get, let's say, somehow to fetch that data that is hidden or clipped, you will probably get garbage data. Okay. But if you want to do that for whatever reason, then you have to set clip to false. Now, most applications would probably just set clip to true. So, okay, let's see the other stuff. Flags, composite alpha. For composite alpha, you basically depends on your bit So there's opaque, inherit, post multiplied, pre-multiplied. Now, the best thing to do this is to first of all fetch the possible composite alpha stuff. But basically this is for transparency. Do you want transparency in your window or not? For now, I'm just gonna go with opaque though. Later on, I should actually do it properly, but whatever. Other than that, there is image color space, image extent, image format, image sharing mode, and alt swap chain, Q family indices. For pre-transform, this is pretty useful thing for phones, but yeah, let's just go with something minimal for now. Transform flags bits. Let's see what we have here. I'm just gonna go with identity. Basically, I'm saying don't change anything about that. And swap chain create info dot. Let's see what else. Pre-transform composite alpha clipped surface. Well, color space. I need to fetch the color space in the formats that are available to actually set these guys. For sharing mode, I'm going to go with exclusive because, well, you gotta have to set it to concurrent if you're willing to share the swap chain with multiple queues, I guess. But in my case, I'm not doing that. I have one queue, I believe. I'm gonna present using one queue. So yeah, what's next? Q family indices. Now we're supposed to set that to the indices, the queues that we're using, basically. So set Q family or indices, and here is supposed to give it the Q family indices. All right, so we do not have this information right now. but I'm just gonna go with key family index right now, and this gonna be a const uint32t. Now honestly, one little thing, since we're gonna be needing to recreate the swap chain though, I probably have to create another function first. So void, I guess, well, it may change later, but anyway, I don't care right now. Create swap chain. Okay, or let's just say auto, right, whichever. Okay, and here I'm going to basically say create swap chain. So why I'm not getting any? My IDE for some reason doesn't give any. I'm not sure what's wrong with my IDE, so I'm going to restart it. Let's go, let's go, let's go. There you go. Now uint32t key family index. Let's go. Now swap chain create info dot let's see, image extend, all of that I still need to get it. Key family indices, present mode. For present mode, honestly, for now, I'm just gonna go with vk FIFO. What? Oh yeah, bits. What? Really? Where is the bit flags? What? Really? Where is present mode? I mean, what type? Am I going crazy or what? Present mode. Well, here you go, but what's wrong with it? I don't know why it doesn't show it. Really? Okay, well, that's weird. Anyway, so what's next now? Swap chain create info. Is there anything else? Pnext, key family indices, clipped. I guess image. Now I basically gotta get the surface capabilities at this point, so let's just get it here. So how are we gonna do that? Well, vk, I don't think there's an raii stuff there. No, of course. Okay, so surface capabilities, khr. Oh, well, how you're supposed to actually get it? Oh, I think maybe you would basically say handle.get what? How do you get these swap chain capabilities? Really? There you go, there's a sample there. Let's see how it's getting the capabilities. Oh, physical device. That's weird. Gotcha, okay, fine. So we need also the physical device. So let's do that. So vk. Well, this is pretty much the Q family, right? So let's just get the Q family. Right, and now here I could destructure that. Const auto reference, I guess. And here we would get the, I do not remember which order I've done them. Yeah, physical device first. Then the Q family index is, I guess, equal to Q family. Right, let's go. And now, where is it? Okay, so const auto surface capabilities is equal to, or let's just say this, physical device dot get surface capabilities khr, and then you give it this surface, which is the handle in our case. Handle. Oh yeah, I need to dereference it maybe? Seems like, okay, weird. It's kind of inconsistent, honestly, but whatever. Oh, I need to make it a const reference. In fact, I'm probably going to actually sort the key family, really. Yeah, I guess. We'll see though, we'll see about that. But yeah. So create swap chain. Should I do that? Yeah, I should. So const Q family, and basically we're gonna get that here. Then I'm basically going to say, and by the way, I don't need the Q family index anymore, of course. Okay, let's go. Okay, Q family. Okay, that works. So I don't need this. Great, swap chain declared here. What? I cannot use it. So I have to maybe do this. Okay. But hold on a second though. Well, if we're gonna do that, then it's not created yet though. Yeah. Well, if we want to call from the constructor, it's still not created, so we cannot access members. Well, interesting. So this is gonna be just like a static function. And then we're gonna have a member function called recreate, which would possibly use the member functions. Yeah, I think, right. So static, and here we gotta pass the key family here too. And we gotta pass in the surface. So const okay, const what? Const vk surface kchar, and then I guess I could take a const reference there. Then basically, hey, yo, bro, you still doing this C++ Vulkan thing on the graphics program in Discord? Hello, Charlemagne Manny. You're still doing? Yeah, here's what we're doing. Yeah, we're still on the grind. So yeah, surface. So here we got that out of the way, I guess. Here we gotta pass in the key family and the surface, I believe. Which is in our case here handle. It's called handle. Okay. Well, in fact, we gotta use this vk_raii thing. Why not? Okay, amazing. Now we need to dereference that. Okay, interesting. And same thing here, I guess. Yes. Surface. Now we got the surface capabilities, which is nice. Next up, we can actually fill up the other stuff. But let me just get a refresher of what's there in the surface capabilities. So there's the current extent, current transform. Okay, we could set it to current transform. Okay, max image count, minimum max image extent, minimum image extent, or minimum count actually. All right, gotcha. Supported composite alpha. Supported transforms and supported usage flags. All right, gotcha. So yeah, let's go ahead and say swap chain create info dot current extent. Extent, I guess. What? Let's go. Oh well. Image extent. I'm going to just set it to the current image extent, I guess. But I don't know, but I do remember maybe in Wayland, maybe current extent would be not valid, I guess. Do not remember. Let me actually have a look at the documentation real quick. I do remember something like this, like that, basically. So surface capabilities, vk, whatever. Well, there you go. I think on Wayland it would give you such a thing, a special value indicating that the size will be determined by the extent of a swap chain targeting service. Well, anyway, I'm just gonna set it to that anyways, until there is a problem. if there is any. So well, yeah, whichever. Now the current, actually let's go with the pre. Why? Well, hold on. What? There is pre-transform. Is there something else other than that? No, there's just pre-transform. Okay, so surface capabilities dot current transform. I'm gonna set that to that. Okay, other than that, there is, by the way, FIFO present mode is always you know, like, it's guaranteed to exist, basically, to be supported. Other than that, there's image color space. Now I need to actually use another function to give the color space and the format stuff. There's the minimum image count, which we can do right now, I think. Surface capabilities dot. So there's minimum image actually there's maximum image count and minimum image count. Okay, so here I'm gonna use, I believe, SCD min and max, or maybe clamp if there is any. Yeah, there is clamp. So here the value, well, I don't know, really. It depends on if you want double buffering, triple buffering, what exactly. I don't know. I think I'm just gonna go with surface capabilities, maybe dot minimum image count plus 1. I do remember something like that, but whichever. I still need to read the documentation more to refresh myself on that, but anyway, max image count, just making sure that it's in the range. But there's one thing that I remember is that there is some special value. Yeah, I guess there's some special value when it comes to the minimum image count and max, etc. Let's see. So contains the smallest value swap chain extends. Unless current extent has the special value described here or above. So there is something about the special value. Not sure what's that, but for now we're fine. I do remember something about whatever. Who cares? For now it's fine. Swap chain create info. Other than that, I think I've done all of them. Image extends, present mode. Now I think it's just a matter, well, there's image array layers. Image usage. Did I do image usage? No, I didn't. So let's do that too. It's simple. Equal to vk image usage flags bits. Let's go, and then let's go with color attachment, since we're gonna use that as a color attachment in the render pass. Next up is swap chain create info dot. What else? Okay, there's also image array layers, which I believe would be set to 1, if I remember correctly. This is, if I remember well, it's like basically, I don't remember the name, hold on. Stereoscopic rendering, I think. Like there is some uses for this image array layers. Basically you would have multiple layers, I guess, in the same swap chain image. And for example, you know that, I don't know, let me actually search it up, hold on a second. I'm not sure if it's really stereoscopic rendering or what exactly. Stereoscopy. Yeah, there you go. So you'd basically have 2 images, and for example you would, I guess, maybe use 2 image array layers at that point, I think. So one for one eye and one for the other eye. Like this is one of the uses of image array layers. One of the uses, of course, but there's a lot. See, there you go. So you would have that 2 images. Alright, gotcha. But for now, I don't need that. I do not have that stuff. I'm just gonna go with one. Swap chain create rate info. Let's go. What else? I think right now probably. Did I set the Q family indices? I guess I did. Yes, I did. So now I just need to fetch in the formats and the color spaces. And let's see how we can do that. So surface formats is equal, well, let's do that, and maybe physical device. Let's have a look. Get surface formats. There you go. KHR. And that would give me a vector. Gotcha. So I think I would maybe use that closure trick again. And basically I would go through let's see, maybe I would use std find actually, or you know what, let's just do it directly, I guess, for surface format. Maybe in surface formats, oopsies, cost auto. What's going on here? Oh yeah, well, need the initializer thing there, and of course we gotta call this guy. Okay, now hopefully physical device. Now I'm just gonna capture everything by reference, I think, for now at least. Variable has complete type. Okay, so let's check that up. If surface format dot format, let's go, is equal to, well, vacay format there you go. So I would basically prefer RGB8, something like that. R8 or BGRA. Let's just go with R8, I guess. Not sure. I don't really need the alpha though, but honestly, hold on a second. Let's go with the Vulkan configurator. Actually, not the Vulkan configurator, the other guy. Let's see. Oh my god, I quitted it. Let's have a look. This PC, local disk C. Okay, bin. Vulkan caps viewer. Okay, honestly, I'm going to actually pin to taskbar. Let's go. Alright, so formats. Well, in fact, surface. And there you go. So the first one is BGRA8, sRGB, non-linear. So I'm going to go with this one, honestly, I think. So B8G8R8A8, isn't it? Yep. I'm gonna go with sRGB, isn't it? There you go. And also surface format dot color space should be color space KHR and non-linear. There you go, I guess. sRGB non-linear, is it? Yep. Okay. Now if that's the case, then we're basically going to return surface format. This is basically the preferred format. Otherwise, honestly, we're just going to return the last one. So to do that, we got to store the surface format still. So let's do that. Formats. Otherwise, if we don't find the preferred surface format, we're just gonna go ahead and select the first one. Why not? Actually, const auto. I guess it's front, right? Dot front. And there you go, we got our surface format. So basically we're trying to find the preferred one, otherwise we're just getting the first one, basically. So that's the surface format, hopefully. And the nice thing about this kind of closure trick, as I said before, is that it will be const, right? And yeah, pretty much. So next up is const auto surface. Well, in fact, no, hold on. What I'm doing. Yeah, it contains both. It contains the color space, of course, and the format. Gotcha. All right, amazing. So now let's actually set that stuff. Swap chain create info, and we may find some function, I guess, right? Let's see. I actually don't think. Yeah, it would have been nice to do with some function that would set both the color space and the format, but apparently it doesn't exist. So image format is equal to surface format dot format, and then swap chain create info dot image color space, I guess. Yeah, surface format dot color space. Let's go. And hopefully with that we're done. I think I probably settled everything at this point. Other than that, we're gonna rely hopefully on the validation layers to tell us if there's anything that isn't right. Image usage, minimum image count, surface transform. Flags, I don't think I need any flags. Yep. There's also set alt swap chain, which would be useful for let's see. I don't know, by the way, why it takes in a swap chain instead of optional swap chain. Weird. Oh, well, because you would only do that if... Yeah, gotcha, makes sense. So. Right, gotcha. So there's also alt swap chain, which would be useful for recreating the swap chain. But yeah, equal to. Now we are in the static function, right? So it's gotta be used by both. Okay. Alt swap chain. What is the type of this guy? What is the type? VK swap chain KHR, okay. Old swap chain. Swap chain. Well, actually, I guess this would be optional, really. VK. swap chain. Well, maybe I would even actually go with raii swap chain, maybe. Let's go. And then basically I would dereference this, I guess. But of course, one little thing, which is I would like to get this by reference, hopefully. No. I think I should probably take swap chain HR by reference. No. Weird. I don't know. I'll see how it goes nonetheless. So honestly, let's keep it simple. Just keep it simple, you know. Let's keep it simple. Actually, I guess maybe it's fine. You know what? Fine. So if old swap chain has value, then swap chain, old swap chain, and then we gotta dereference that guy to get the interline value. I think that's what I'm gonna do basically there. Other than that, now we can pass here null OPT, null optional, because basically at the start we do not have any old swap chain, right? So yeah. Now let's see what arguments we need to give it. In fact, where it's even getting called though. Am I creating the surface already? Yeah, I'm doing that. So what I'm required to give, I guess the key family, if I remember well. What it requires, bro? Yeah, the key family. So what's the problem? Weird. What's the problem? Really? Hold on a second. So surface. Oh, what type is key family though? Oh, I see. Gotta dereference that. Alright, gotcha. Right, that's pretty much it, I believe. Right, now just gotta make sure to update it in the other place too, though. Here. This is error prone, but may do something about it later. Okay, so that should hopefully work out, I think. So at first you create a swap chain, but of course we're still not creating any swap chain right now. In fact, let's create the swap chain now that we have the swap chain create info. So vk raii swap chain khr, and then here we're gonna pass the, well, first of all we need the device though. Interesting. We need the device, then we need the swap chain. Sorry, the create info. Okay, sure. Gotcha. So swap chain create info. And let's go. Now we need to require the device, interestingly. So we're gonna go here with the device too. So const device, const vk raii device reference device. Okay. There you go. And of course I'm going to return this guy. And I believe that's it. Fully. And then now we need, of course, to pass in the device too. So can I get the instance from the device though? Hold on a second. Let me see what I can actually access from the device. Where is the device? There you go. So let's see. Device. Get. Can I get the instance? No, I cannot. Gotcha. So I have to pass them individually. Okay. Because sometimes they do allow that. Kind of consistent. But anyway. So where's the device? Instance. Alright. Well, so there's const window, instance key family. Let's also provide it with the device. Const the raii device reference device. Let's go. Now that's nice. Now let's actually change the constructor stuff. So after the instance, I have the device, isn't it? Yep. Now let me make sure to update it here too. Okay. All right. So yeah. It should technically, or should I say theoretically, work. Okay, I guess there's one way to try to find out. Okay. But hold on a second, what I'm doing, hold on. I mean, yeah, we're gonna create the swap chain, but oh, what the? There's an exception. Amazing. And we don't have anything from where it's coming. Amazing. Perfect. Oh yeah. So these are all infos. There's no error, no warning. Weird. Doesn't tell us anything about where the crash have happened. Amazing. Perfect. Let's see if, well, what if we don't create the swap chain? Hold on a second. Okay, so the problem with creating the swap chain. Now maybe I'm lacking an swap chain extension possibly. Hold on, where's the device? Device. There you go, the info. Let's see if this would fix it. Hopefully there is a zip enable extension names, so that's interesting. Now let's see, vacay layer, no, swap chain. Swap China. Swap China, right. Extension. Where is the stupid macro or whatever that is? Really? Finally. There you go. And well, device extensions. This may be the problem of the crash. I don't know. Let's see. Cast auto device extensions. Okay, let's see if this would hopefully fix it. Otherwise, we're in trouble. And yeah, we're in trouble. Okay. So what I'm missing? Now it doesn't even tell me which line though. It's stupid. I guess it's maybe coming from some layer or something. Hold on. What if I go with release though? What if I go with release? Yeah. All right, interesting. Now the real question that I want to ask though, hold on, is Vulkan swap chain extension. Because last time I've checked, maybe they're deprecated, or maybe not. I don't know. Extension name. It's kind of confusing. Well, I'm just gonna leave it. Where is it? Let me make sure it's initializer list though. It really doesn't give anything about what's the source. Reading location 0x00004 0. Copy value, I guess. I don't know. Let's see. Do I need maybe to do something special to like load the extension maybe? Like the extension pointers possibly? I don't know, but honestly at this point I think I'm just gonna stop the stream until tomorrow or until later. So I'm going to investigate this problem offline. So yeah, I mean off camera. So yeah, that was it for this video and see you later. Goodbye everyone.